Get through 8.5. My sound is now working. So, here's the first thing I want to show you guys. You probably at this point, if you've been doing the practice as it's been assigned, are feeling pretty confident with solving equations, which is good. That's great. But I wanted to show you where this ends up going. So when we get into physics and we get into looking at how the world works, we use some equations to model how things fall or how things move through the sky. So this situation right here is an equation to solve for the amount of time that it would take for a cliff diver to reach the surface of the water. So you can see how much more complicated it gets because what we're trying to equal is an elevation of 0. He currently has an elevation of 64. What do you think this negative 16t squared is? What works against you, or actually maybe works for you, depending on how you think about being a cliff diver? Ozzy, what do you think?
Maybe it's how much time it takes him.
Now t is going to be your time.
Maybe it's how fast he falls.
Yeah, we're looking for a different vocab word, Dom. Ozzy? The rate of what?
The rate of how fast he falls.
So that negative 16t squared would also describe. Julian?
Resistance.
Not resistance, actually. This does not quite compensate for resistance. Sam? No, that's the positive 64. Andrew? You're right. This is the rate of gravity in feet per second squared. Because as you fall, you speed up.
Second have a square.
Because like 3 seconds, 3 squared would be 9. So that negative 16 would be multiplied by 9. So when you solve this all out, you end up with an answer of 2 seconds. And you actually end up with an answer of 2 or negative 2. But negative 2 doesn't make any sense.
Then you'd be going up.
Well, so instead of jumping off the cliff this way, essentially negative 2 would have been back in time if I fell off the cliff that way. Like, it just doesn't make sense. Because that actually models a parabolic situation. So this is slightly off center. The center should be on the vertical axis, but this would be the cliff diver falling, and this would model 2 seconds, and this would have been the 64 feet high. So, but that's way beyond what we're doing right now. I just wanted to show you guys where you're going with all this. So, that doesn't really matter. I just wanted to show it to you because it's cool. So, we were on this problem at the end of class yesterday. Did anybody take on the challenge to solve it completely out and you're confident enough to come up and show your peers? I left the end of class by saying if you chose to, you could solve this out on your own, outside of class. Almost. I know some of us got close. So let's start setting this up then. Ellie!
Hi.
Let's start setting this up. What do we know in this problem?
We know how many invitations we're sending.
Yeah, and that they're all the same, which we would hope, unless some people get special invitations.
And they all weigh more than 1 ounce.
They all weigh more than an ounce.
And that mailing an invitation costs 44 cents for the first ounce and 17 more cents for each additional ounce.
Sweet. So, and we know the postage total is $15.60. So anytime you see like repeated objects, what do we do when we have like repetition? Mathematically, we end up just multiplying. So double would be if we only had 2 things, but when we have more than that, we just multiply. So we're going to set up 20 invitations, and we could write invitations in here and then replace it out, but I think we've solved enough of these that we can start to build in there. What do we know about the invitation? Andrew?
That it's 44 for the first ounce, and that it's 17 hundredths
And do we know how much it actually weighs? More than an ounce is all we know. You don't have to write this, but here's what we actually know. We have the initial ounce, which I'm just going to abbreviate it OZ. We have the initial ounce plus some more. We don't know exactly how much, but we do know, like Andrew just said, that initial ounce is 44 cents. The more will be 17 cents times, I'm going to use Z here because the ounce abbreviation is OZ, times each additional ounce. So however many extra ounces we have, we're going to get charged based off that. And then we'd set this.
1560.
Yeah, just equal to the 1560. Now, we have options here, which sometimes makes things more difficult for us. By the way, don't let you guys leave without passing out papers. What would you do, Jaslyn? There's multiple ways we can solve this. What would you do?
I think instead of doing multiplication, I would avoid that and do division.
I love it. We would avoid the multiplication that we would have to distribute, but instead of doing that, what would you divide by? Sorry, you have a full mouth. So we would divide by the 20 so that it never multiplies. Somebody yesterday commented something like, so is this sort of like time travel? Like we can stop it from ever happening? Kind of, not really, but if you want to think like that, sure, because you know I'm kind of nerdy like that as well. So all we're left with on the left-hand side is my 44 cents plus my 17 cents Z. So we don't really need those parentheses anymore. Sorry, I had opened one and I decided to erase it because I can't do what's inside the parentheses. So since I can't do it, get rid of them. Then that's going to equal, well, what's 1560 divided by 20?
It is 78 cents, or 78 hundredths.
Yeah, you're right, 78 cents. So what is this actually telling me? Like after we divided by 20, what is this communicating?
How much it is for 2 ounces of water, or for an invitation that's more than 2 ounces?
How much it is for an invitation that is more than an ounce. So this is your one invite price. Well, we know from that one invite, there was 44 cents automatically there. So what would we want to do, Noah?
Get rid of it.
Get rid of that 44 cents that was automatically there. So we subtract the 44, and we get that 0.17 Z, or 17 hundredths of Z. Is equal to 34 hundredths. And Ozzy, your answer here?
0.02, or just 2.
It's just 2 actually, because how'd you get there? What'd you do on both sides?
I divided by 0.17.
We divide by the 17 hundredths. Guys, when they both have the same decimal locations, ignore the decimals. Because this is 34 hundredths and that's 17 hundredths. Just think about it as 34 over 17. Any questions, comments, concerns? We never distributed, which is nice. You could have distributed first, then subtracted, then divided. It does not make a difference. It's just whatever way you prefer. Flip over to the set 8-5. If we can come back to these exemplaries, we will, if we have time at the end of class. So we are now just applying this to solving problems. So a lot of this I'm going to hopefully put on you guys, and we're just going to come back briefly to discuss things. So we have an example of a model here. Models are extremely useful for helping us solve these problems. So we see that we're shipping 5 samples to a client. G is going to represent the grams, I believe, no, ounces. So G they just use as the weight for each sample. So what starts with G?
Games.
Grapefruit. Games. Okay, games. I like board games. So we're shipping 5 board games to a client that wants to try them out. They all weigh the same thing, but we have to put them in a box. So here's my model for what I'm shipping. My total weight is going to come from my 5 games and my box weight. So when I set that up, I can really say 5G, and now I know that my box weight is 8 ounces, so I can really say we have 5G plus 8. So then, to figure this out of what the weight of one sample would be, what can I do based on this model? Like, we can write this as an equation, but if we just look at the model here. Sam, what do you think? We can get rid of the 8 ounces. So if we get rid of this 8 ounces, hello, Smarting. Good morning, I'd like you to come out and play. There we go. If we get rid of this 8 ounces, we also have to get rid of an 8 up here, which makes this become 39. So now what we have is 5G equals 39. How do I then solve for G, Sean?
You have to divide by 5 on both sides.
We have to divide by 5 on both sides. Guys, think easily. If this was 40, what's 40 divided by 5? 8. But it's 1/5 under that, so it's 7.8. Label of ounces, because we were told it was in ounces. So a pound is 16 ounces, approximately half a pound for each of the items that I was shipping.
Okay, that's a lot. Why did Americans start using a complicated system of ounces?
I agree, and I have no good answer.
Because we are really complicated. Like
We actually signed the treaty of the meter that said we were going to switch to the metric system.
Yeah, but
And then, like a good American deal, we backed out.
yeah, but my brother asked me like, how do they even come up with such a complicated system?
Yeah, 5,280 feet in a mile. Who would have wanted to do that? I mean, there's reasoning behind all of it. Like how we used to actually measure things based on like your body, which
But
was
then
way
everybody
like...
was like different sizes.
Right, yeah. So there's reasoning behind our unit of measurements, but it's not good reasoning. So I agree, we should switch. All right, try this example on your own. Well, on your own with your people close by you. Actually, do the example and the got it. If you're able to do both, go ahead and try to set up a model and or equation. You decide how you want to solve this. Actually, at least on the example, you need to show me a model. Your model doesn't have to take the whole box, but I need you to show me that you can visually represent these situations.
How do you,
Take a minute to read the problem first.
Wait, is it the total cost of both of those? Of both? of
Total cost of everything. So careful with your model. I'm going to go ahead and jump back in for a second. When we, and I'm going to color code everything, which guys, I really advise that we have highlighters. When we look at what we're buying here, who can kind of synthesize what we're buying? Well, I'm just going to keep using cards actually. Ashley, can you like put together what my friend and I are buying? Yeah, we both buy a software package. So there's one software there and one software there. So I've got a software package and a software package. And then, what else? Yeah, months of gameplay. I buy 3 months. My friend buys 2 months. How many months is that together?
5 months.
5. So I've got a month, a month, a month, a month, and a month. This model should take up the entire width of this box. If it does not, fix it. And that's going to equal your $115. Sam?
I know what to do.
What do we do?
Okay, so you can add the two software packages together,
So what are you actually doing? Mathematically, we are,
combining two
what do we call them when they like each other?
like terms.
Yeah, we're combining like terms. So we combine these to get 2s. What else?
And then you can combine the 5 months.
We can combine the 5 months together to get 5m. Now I can actually substitute now. I can actually substitute
Oh, wait,
now.
Since you know what the value of s is, can't you substitute that for time?
Since we know the value of s, where we see s, we can actually sub this out for a 20. So this really,
Wait, wouldn't it be? Okay.
Yeah.
so really the 2 times the 20 gives me $40 for the software and then 5 months.
And then you can subtract 40 from your total cost.
So now, what I'm going to do to both of these, exactly what Sam said, get rid of your 40 here. So we're going to do minus 40 down here and a minus 40 up here. 115 minus 40.
That's 75.
So now $75 is equal to what?
5M.
The 5 months.
And then
Go ahead, take it home.
Okay. And then you divide by 5 on both sides.
We divide by 5 on both sides, and we get that the month
15.
is $15 for each month of gameplay. Does this make a little bit more sense with how we use the model now?
That's like a cheap.
Jeremiah?
Oh yeah. Why don't they just buy the game and then the thing that they're doing?
Dude, I'm just making problems to do the math.
I know, but
Don't overthink this.
but they could have saved money.
Dude,
doing
these
it.
problems were written before like Xbox Live was really that popular and before like the act, so you're overthinking it. Just this is like the olden days of computer games where for a game I had to pay for the monthly subscription. Yeah, some games, but a lot of kids just play on like Xbox or PlayStation now. So, any questions mathematically, Elena?
Well, did we have to put all the work? Because for my bar graph, I just put 40 and then 5M. Did we have to?
That's okay. Like, as long as you know how to think this out, you're fine. So as long as it made sense to you. Try the got it on your own. I am going to give you guys a couple minutes to do this. You do not have to set up a model. I know it says make a bar diagram, but if you choose not to, you do not have to. If you just, I know myself, I really think in numbers and variables. I don't have to have a picture. Sometimes it helps. Hey, random question, because I'm making my list of things to go over break. Would it be beneficial if I had like a resource table in the middle of the room with like post-its, pencils, calculators, that sort of thing?
Yes.
Like where this is, if I replace this with a like a table thing?
Well, I wouldn't want to put it in the middle of the room.
Well, why not? If you need stuff, isn't that a central location?
And nobody would want in the middle of it. That's where everyone walks. Maybe on like
But
the
people
side.
walk around it.
No, there's
So, if the real point is, if you make a bar diagram, you may not have enough space. If you need post-its, feel free to come grab them.
Do I have to create a bar diagram?
Dude, I literally said no.
Oh, okay.
Literally just like 3 minutes ago. I said you don't have to.
My work and I didn't hear you.
Wait, so you're gonna be here for winter break?
Some of it. Until I go home to my family. Not like here all break, but I live 2 miles that way.
Live in the janitor's closet.
You know, some days I spend more hours here than every day I spend more awake hours here than I do at home. Oh, now would be a great time for me to pass out your papers.
Everybody does.
Just revisions and things that people have turned in.
Oh, that's what you mean. I thought it was like moving home.
So, reminder again, we have your Chapter 7 mastery on Friday, tomorrow, and then Chapter 8 on Monday. Because I'm out at the WEC.
Yes. Wait, I don't think I know that.
So, let's bring it back together.
Wait.
No.
I'm almost literally done.
I mean, you can keep working. I'm just going to set up an equation to make sure that your equation's correct. So, Dom, do you have an equation?
Okay, well, I didn't set up a graph or anything.
Okay.
So I just did, so we know that you rent it for $39.95, so I did 39.95 plus 0.99 M because it's 99 cents a mile.
Yeah, so we
times
have-
sold for miles.
What would this that I highlighted in yellow be? Would that be variable or constant?
Constant.
And this in green
Variable.
is variable because we don't know how many miles. So I'm actually going to set up these on the right side of my equals just to make this look a little different than what we've been doing. Remember, it doesn't matter how you like left or right or where the order of your addition. We're all commutative. What's this equal?
Wait, you're missing
Yeah, you're
Dom?
missing how much he fills the tank with. 65.92.
Which, if we know what it is, I highlighted it in yellow because it's a constant. And then,
Is equal to $164.67.
what's the first thing you'd want to do here, Acadia?
You want to add the two that don't have the variable?
Yeah, on my right-hand side, I have values that can be combined. I have like terms. So, nothing changes on your left side. I'm going to go ahead and just put my variable term first because I don't have a calculator in my hand right now. That's almost $40 plus 65. 105 minus the 105.27? Yes? No? Maybe?
No.
I believe this should be 105.27.
105.27.
Yes, that's right. That is right.
Ha! Whoever said no.
I didn't.
Well,
wait, no.
I did it a different way.
Yeah,
You
so
did the
I.
addition a different way? Or did you subtract each of those individually?
I subtracted each of
Okay,
them.
that's fine. Many right ways to get to
Yeah,
Florida.
I know.
Oh,
I
wait,
don't like Florida. Can we use Texas?
Oh, I got 2 5.
Sure, you can go to Texas.
I've never been to Texas, so can we not use
So
Texas?
now, still out. Monica, what do I do now?
Oh, now you minus 105.27 from each
Be
side.
careful, the and is the decimal point. I'm just trying to make you guys sound really, really intelligent. The and, when you say it, represents the decimal point. So, do you want to go ahead and finish us out?
Yep.
So, my right side still has that 99 cents M. What's your left side now?
59.4.
Fif-
40.
Ah, yeah, it's money. So, $59.40.
Then you divide by 0.99 on both sides, and you get 60 equals M. Oh,
Yeah.
Got it.
I did it.
So, what's that communicating? What would the label on that 60 be?
Dollars.
No.
Cents.
No. Miles. This was solving for how far we drove the truck. Guys, this is real math. My buddy Dave just moved 2 weeks ago, had to rent a truck. This is exactly what happens. You pay a fee to get it. You pay a mileage fee for every mile that you drive. And you have to fill it up with gas before you take it back, or they charge you up to $7 a gallon.
Why?
Because it's in the contract. If you don't fill the truck up, like all the way, they put gas in it and they can charge you up to $7
I
a.
have something to say about that.
Okay.
How is that fair?
Yeah.
It's not.
After you fill it up all the way,
Government-
you
No,
still
but
have to use
if
miles to get
no,
drop
you
back
fill it
off.
up right before you take it back. So when you get the truck, it's full on gas. This would have been, geez, my smartboard's off now. This would have been, come on, how much gas you put in on your way to take it back, like to return the truck. When you get it, it's on full, you use it, you drive it, whatever, you go to return it, fill it back up.
I know, but while you're driving back to drop it back off, you're gonna lose miles.
That, they don't care. Like, that's like a mile or two. Your gas needle doesn't move based off a mile or two. Because there's gas stations, like, everywhere. If you're going to rent a truck, there's a gas station close by. Anish?
Did you combine $39 and $95 plus 65?
We did.
No. Add them up and then subtract for 160 for 160.
We did.
Oh.
So we added them, and that got us, I don't know how my smartboard just got well. That got us to my 105.27. Then we... Ghosts. Then we subtracted it from both sides. Then I kind of shifted my work over here, and we did the division, but now it's all disappeared.
It's lying.
So, this next problem is actually a really cool problem. Well, that's interesting. I do not need to sign this. So, there is a direct conversion formula. Speaking of why America uses a different system that doesn't make any sense, going from Fahrenheit to Celsius.
Why did
So,
people invent temperature?
that's just two different temperature scales based on what different like chemicals people were using, what numbers they assigned to their markings. Go look it up if you want to know more about it. Like, there's a deep history to why it is. Celsius is the simpler measurement system. I think Fahrenheit happened first, just because the chemical that they had that would change size. Because we used to use magnesium because it changes size with temperature. But that range between freezing and boiling is from 32 to 212. It's really complicated. So somebody, probably a mathy person, took Fahrenheit, brought it over to here, and said, I'm going to erase all these markings and make it on a scale from 0 to 100. And then they reset it all. Like, that's essentially what they did, in brief. But here's our formula because of the weird change, the weird difference between the scales. So if you know the Fahrenheit formula, the Fahrenheit temperature, you use this formula to find your Celsius. If you know your, it's not on this paper, I think I give it to you somewhere else. If you know your Celsius formula, I got ahead of myself. If you know your Celsius temperature, we need a different formula. Because if I know my Celsius temperature, plugging that in here would be really, really complicated. So what we want to do is figure out how we can isolate our F. That's our task right now, is how do we isolate this F value? So take a second to think about it. I got to reset this. Jeremiah, what's your question?
1 degree Celsius, how many is that?
There's no direct, it changes. Like,
What?
not that it changes, but it's like you don't do it based off a unit rate. You do it based off the formula because there has to have that weird, this subtraction makes it not a straight conversion. So it's not like half a degree Celsius is a degree Fahrenheit. Like, there isn't a straight conversion like that because of the subtraction.
So weird.
Did you get a new computer yet?
No, this is still, I think this weekend, maybe tomorrow. Yeah.
How would you find for Fahrenheit if you don't know the Celsius?
Exactly. We are using two variables here. So when we end, we're still going to have two variables because we don't know either of them. So the first question that we need to ask is, how do I start isolating the F? Well, to start isolating the F, I have to start by isolating the parentheses that F is in. How do I get rid of the object attached to the parentheses? Julian?
Don't you multiply by the fraction?
Ooh, the what of the fraction? The reciprocal of the fraction. So I'm going to rewrite my whole formula right here. Celsius is 5/9 times F minus 32. We want to start by multiplying by, okay. This is 9/5. My smartboard is just acting up and I don't know why. So we come over here and multiply by 9/5. Now my left-hand side is 9/5 C, while my right-hand side has gotten simpler. The 5 on top and bottom cancel each other out. The 9 on top and bottom cancel each other out. And my right-hand side is just f minus 32. What, Mr. Smith, do I do now to get the f by itself?
You subtract 5, or you add 32.
We add 32. No, wait. We talked about the process being undo the arithmetic, then undo multiplication division. But we just undid multiplication division and then undid arithmetic.
Commutative?
No, not commutative. Why do you think this one solved differently?
Because invertible.
Two variables?
Not. That's actually not why. That is part of why it's a little bit more
Because
complicated.
it's fraction. Can't you do it either way?
Crap.
Because it has a fraction.
Because it has a fraction where?
Before the parentheses.
Because we have a quantity separated, that is going to change how we do our solution process. So I just wanted to make a note of that's how we solve equations when they're set up standardly. This is not standard because we have a quantity separated from everything else. So this kind of breaks our rules a little bit. It changes things. So don't think that that rigid order is always what has to happen. Here, it was simpler to multiply first and then add. So now we add 32 and add 32. Can 32 add with my 9/5 C?
You can add it to 9/5.
Wait, no, you
But
can
9/5 C is
Oh.
together.
No, you can't.
These are not like terms. They can't be added. So what I end up getting is that my Fahrenheit temperature will be 9/5 the Celsius plus 32.
Can we actually use that equation to figure something out?
Yeah, the conversion between temperatures. So go ask Kabilo when you have class with him when we use conversions of temperatures. And you can ask him about the difference between Fahrenheit and Celsius because you do a lot of more temperature work in there. And I can almost guarantee you're going to use Celsius because most science, like most labs, most scientific research, most of that, because Celsius is kind of the global measure, uses Celsius. We only use Fahrenheit here really to talk about weather. Now, the benefit of Fahrenheit, though, if there's 100 degrees between freezing and boiling for Celsius, and there's almost 200 degrees for the same distance of Fahrenheit, which one's more accurate?
Fahrenheit.
Fahrenheit's actually more accurate.
Because there's more different.
There's more degrees. Yeah, there's more numbers to change
So you
places.
can point more accurately.
But sometimes with Celsius, they do the tenths of degrees to be more accurate because it's a system based around tenths and it's easy to do that. Fahrenheit, they could do that also, but then that'd be super duper accurate and we don't really need to do that. If you get a really nice temperature gauge like digital, it'll give you the tenths of degrees. It'll be really accurate. Sean? Oh, okay, so when he's back, ask him about converting. And actually, I think his sub is a sciencey type guy, so you could ask him. Yeah. So, the spacecraft Magellan. This is real. This was a real spacecraft. Launched May 4th, 1999. I remember this. I was 10 years old. I think it's a sweet name. So, hey, Mr. Estes, you remember Magellan spacecraft back in 99? They're like, what, really? Because, they think all these problems are just made up. So, it flew for 463 days. It was up there for over a year. It went to Venus, and it, did it go around? Did it come back? Or did it just go and send stuff back?
It mapped it.
Yeah. So a lot of things we send up into space, we're just like, hey, send back data and goodbye. We just let it keep going. So it went to Venus and it traveled 806 million miles. That's unfathomably far.
Isn't that 3 times around the planet?
I don't know. I don't know the accurate circumference. Don't you love when these guys ask questions like that? Oh, isn't that 3 times the planet? So, if we want to talk about its rate, its speed, how fast was this thing traveling? we have our formula that I nickname our dirt formula. Distance equals rate times time. So set up, over here off to the side, a d equals r times t. And actually make your t capital. Let's first figure out miles per day, because that'll be the easiest solution.
Then you can multiply by 365.
Do be careful. So hang on. Just depending on what you're going the wrong direction. If we want to get down to miles per hour to talk about like what we
Then
measure
divide it
speed
by
in,
24.
yeah, then we'll have to divide. So what's my distance? Do I know my distance?
806 million miles.
806 million miles. Go ahead and write out the whole thing. Add those 6 zeros on there. Do we know how fast it was going? Well, no, that's what we're solving for. How long did it take? 463 days. Now, here's the thing. Be careful with what the rate is asking for. Right now, we're solving for miles per day, but they want miles per hour, so we'll get there. Elena, what would I do to isolate my R value?
Do like the 806 million miles divided by the 463.
Yeah, we got to get rid of 463, so we divide by this. And we get that our rate. I need help.
Oh, I got it. 174,806,820.
Can anyone verify that? Just because we have a lot of zeros here.
There's a zero.
No, there's another zero after the 4.
Doesn't matter.
After the 4, there's another 0.
So then is it
Alright,
1,740,000?
1,082.734.
What? Okay. That, yes?
3-4.
Okay. We're getting accurate.
That's good.
So this, we can't just leave like this though. We need to put a label on it. We need an accurate label. So this was miles per. We're going to set up the per as the division. What goes in the denominator? 1 day, right? Now this goes back to what my chemistry teacher called stoichiometry. I don't know if you can verify if that's a real word or not. But I with how she talked, we literally never knew if she was making stuff up or what. How can I turn my days into hours? Andrew?
Since it's 24 hours in the day, would you multiply by 25?
So I want us to get in the habit of exactly what Andrew just said. Multiply. We're always going to multiply. Even when we're technically dividing, we're going to multiply. So we're going to multiply by our conversion factor that has to get rid of days. And if we have to get rid of days, where does it need to go in this fraction, Ellie?
It goes on the top.
It's got to go on the top, which means that hours has to go on the bottom so that I can end up with miles per hour. Then fill in your numbers. 24 hours in 1 day. So when we think about multiplying straight through, the 1 does nothing. The 1 does nothing. We just really have a division to do. But remember to multiply by the conversion factor, then figure out what you're really doing. So if we multiply straight through the fraction, here's what I'm saying is we could do extra work, but we don't need to. If I multiply straight through here, I'm going to get 1,740,820. Like multiplying by the 1 does nothing. If I multiply straight through here, I get 24. So all we really need to do is this value divided by this value. And we'll end up with miles per day. Or, sorry, miles per hour.
Do you want that?
Ozzy?
I have 41,779,637.
Now
That
wait.
doesn't make sense.
If we divided by 24, how'd we get bigger?
No, we got.
Numerator, denominator.
534.
Julian, you're waiting patiently.
72,534.197.
I'm going to leave it at just 534. And it actually says nearest 100, so we're more accurate than we need to be. Guys, when you're on the highway, you're maybe going 72 miles an hour.
Not 70.
This is 72,000.
That's a lot of money.
That's 1,000 times faster than you travel in the car. That's face meltingly fast.
Wait, so there was a human on that? How are we talking about in connection
There wasn't. Yeah, that's.
Like, if we did, wait, would they be like moving super slow then?
They'd probably be dead. Like,
Not fast enough. But time would be slower.
How do spaceships work?
they don't go. They go really fast. But if you're going this fast, you're always strapped in and you're in like a suit and everything. Like you're not just floating around going this fast. But once you get up to speed, that's the weird thing about acceleration. Like if you've ever been on a train or anything like that, once you're at speed, then you can move around because you're acclimated.
And airplanes.
Yeah, anything like that.
So could we have put humans on that?
It depends on the acceleration force. Depends on how fast they got to that speed.
That would be longer.
But yeah, then that comes into the argument of like, how does time change as you're traveling that fast?
That's a good problem.
Yeah, I love those sort of problems. That
It
involves
took me a while to get that one day over 24 hours. I used to like
the conversion
like, How
factors.
do you just do that? But that's really
It's one. Yeah, you're multiplying by one.
Yeah.
That's where that's
okay.
conversion factor is anything that equals one.
Yeah.
Yeah. We got like 2 or 3. Dude, I love sitting in Mr. Estes' class. I can't if he's teaching close and I need to get work done. I have to put headphones on because I can't like not engage. Try this one. Orca whales. Pretty sweet. Not that huge compared to some of the other whales. They swim at a rate. Now you're given the rate of 704 feet per minute. Ooh, pay attention to your units. How long will it take to swim a distance of 26,400 feet? Fortunately, in the same units. Monis was asking why America chose our units of measurement that we did, and I said, that's a great question. I have no good answer.
Got from English,
Yeah.
and then we never got rid of it.
We actually lied about getting rid of it.
There was a, I should bring that up in more detail, not just in general. There was a pro who tried to land on Mars. And, yeah, so it was a joint effort.
Okay.
And Americans always use feet for this.
Right, yeah, and we use
But
negative
the-
16 t
but
squared all
people
that.
built the pro, like it was a joint Canadian.
Of course.
They coded in meters.
Oh, man.
And it just crashed.
Yeah,
Like,
it was going like too fast.
It
And
just flew right into the ground.
so, like that problem that we talked about at the beginning of class where it showed the cliff diver, I showed them some quadratic stuff just to see a little bit. We use negative 16 t squared because that's our feet squared for gravity. Meters is negative 9.8 meters per second squared, or like so it's a different value in the calculation. I mean, that was probably millions of
And, you know, a
dollars.
small error over distance
Yeah.
is bad. Like
It's
that
huge.
angle, if you get like a 0.5% angle over a long distance.
Oh, it's. I mean, you'd miss the planet potentially.
Well, that's what happened.
We are out of time. I don't want to keep you guys late for your next class. Did anyone solve how long it would take? Anish? 37? Anyone verify it?
Yeah.
There we go. Be ready for the chapter 7 test tomorrow, guys.